Hi class, this is Ms. Schwan. This is number 3 on 7.2. It says, suppose the efficiency of a certain drug is 0.58. Consider the sampling distribution, sample size n equals to 112 for the proportion of patients cured by this drug. Find the mean of the distribution and the standard error of this distribution, also known as the standard deviation. So one thing that you have to be careful of and be note of, that they're giving us a proportion, right? And they're asking for the sampling distribution for the proportion. And that's going to change because this is no longer the mean. In 7.1, we saw formulas for the mean and how to find the standard deviation and the sampling distribution of the sample mean. This is a sample proportion, so we have different formulas for this. So and we have different notation. It's mu sub p hat, and it's sigma sub p hat. So we're no longer going to use, we're only using those same formulas in 7.1. And we have to be careful with 7.3 when you get there, because sometimes you're going to use the formulas that you used from 7.1, and sometimes you're going to use the formulas you were seeing now. So you really have to pay attention when you get to 7.3 of, is it a proportion problem or is it a mean problem? Okay, so this one says, what is the mean of the distribution? Well, the mean of the sampling distribution of the sample proportion is equal to the population proportion. And this is kind of intuitive, but like if we took a lot of samples of size 112, and what would most of the samples come back saying? Well, if 58% of this drug, I guess this certain drug is efficient 58% of the time, and then that should be what most samples are coming back telling you, because that is actually what the population is. So yeah, this is going to be equal to the 0.58. And it's always equal to just that proportion, or sometimes it's in a percent that you have to turn to a proportion, but into a decimal percent, into a decimal, but it is always kind of stated in the beginning of the problem. And then what's the standard error or standard deviation? That is always for the sample proportion. It's p times 1 minus p all over n. So we just have to be careful with how we input this into the calculator, because we could easily get the calculator not doing it correctly. The common error is some students will calculate p times 1 minus p. They'll find the square root of that, and then they'll divide that by n. And then that is not correct, because the n has to be under that square root as well. And that's kind of hard to do on a scientific calculator. Sometimes if I were doing it on a scientific calculator, I probably would calculate this numerator first, get a number there, get a denominator there, and then divide those, get one decimal answer there, and then finally take the square root of that decimal answer if I had to do it on a scientific. But with TI-84 calculators, you can make sure that when you input it, it actually looks like the way it looks right here. Okay, because it will get it wrong unless people put it in the calculator wrong. So I'll show you how to do it on class calc. But this I'm going to plug in for the P is the population proportion, the 0.58. And then 1 minus 0.58. And then our N is always the number in the sample, 112. So like I said, this is a tricky part. So like I go to my class calc, and then I put square root. I put SQRT, and that when I hit the T, it automatically becomes square root. Then I put parentheses, because I'm going to tell it this is everything inside the numerator of this. So I put the 0.58 times, and I put parentheses 1 minus 0.58 in parentheses, and now in parentheses to show it in the numerator. This is all my stuff I want to be in the numerator. Then I press divide, and notice how it made the square roots bigger, so it's obvious that this denominator is still underneath the square root. And then I put the 1/12, and there's my answer. This is the most accurate way to do it, by putting it all in the calculator at once. If you were to do like 0.58 times 1 minus 0.58, find an answer, and then divide that by 120, and then like round that answer, then take the square root and round that, like that wouldn't be good. So it's the best way to do it. Putting it all in the calculator at once when possible. So the answer here is 0.0466. So let's go back to this. And they said accurate to 3 decimal places, so 0.04, and let me see what that would have been. Yeah, it would be rounded to the 0.047. Yes, that's exactly what we get. All right, and then the mean was 0.58, just as we expected. All right, well, I hope you found this valuable, and have a great day. Bye.